So today we're going to discuss about writing and graphing quadratic functions when given a point and a vertex. So how do we do that? So for our review, vertex form is f of x equals a parentheses x minus h parentheses squared plus k, where your vertex is your h comma k, and your point for this particular topic will be our x and y. So let's begin. Our example number 1, we have vertex -2, -2, and point -1, 1. So first, let's tackle the equation. So how does this work? So what we're going to do is we're going to substitute our h and k on the formula. So always, whenever you're substituting, make sure that you are changing your variable into a parentheses, okay, and then squared plus your k. So what we're going to do is to plug in -2, that is your h, and -2, that is your k. Now, please remember that whenever we are graphing or whenever we have our equation, the value of a is very important because it determines whether your graph opens up or opens down, or whether it is wide or narrow. So how does this point play its role? This is your x and this is your y, which means that for whatever value of x, you're going to have a y. In this particular case, if your x is -1, definitely your y is a 1. So what we're going to do is substitute it here so we can find the a. So how does this work? So it says here that your y is 1, so I'm going to substitute that there. And then I will have my a, and then my x will be your -1. I'm going to copy this down. And then I'm going to solve. As you can see, we just now have one variable, which is the a. So now we can determine our a. So let's begin the solving. In the order of operations, we do PEMDAS first. I apologize, I forgot the squared. So this is now going to appear like -1. Double negative is +2. Squared is there. You just copy it. Plus -2. And that's 1 equals a. That's +1 inside squared. Double negative means minus, so -2. By the order of operations, after the parentheses, you do the exponent. So 1 times 1 is 1. So 1 equals 8 times 1, so that's a 1, -2. Order of operations again, that's times. 1 times a is 1a -2. So for us to isolate our a, this has to go to the other side. So therefore, we will have 1 plus 2 equals a, and your a is now a 3. After you have the a being at 3, we now have our equation, which would look like this. That came from the h right there, and squared, that is your k. So this is our equation. So let's try to graph this. So the graphing would look like this. If your vertex is -2, -2, that's your vertex, that's your v. And then your point is -1, 1. This is your point. So that's your -1, 1. This is your point, and that is your vertex, which is -2, -2. Your parabola or your function looks like this, the other half. Now, we all know that it is symmetrical, so we can just approximate and say that the other point would be on this side. So that is your graph. Okay, for our example number 2, our vertex is 2, comma 1, and the point is 4, comma negative 1. So how do we write the equation? So our equation is y equals a parentheses x minus h squared plus k. So once again, for us to be able to know the a, we have to substitute all these values in all these variables. So again, this is your h, this is your k, this is your x, and this is your y. So how will that look like? For the y, we have negative 1. That be equals, the a is what we're looking for, so it stays there. For x, we will have parentheses, copy the minus, parentheses for h, close parentheses squared, plus parentheses for k. So our x is 4, our h is 2, and our k is 1. Again, by the order of operations, we are supposed to be doing parentheses first, and we can combine 4 minus 2. So let's rewrite everything. 4 minus 2 is 2. Copy the squared, plus 1. Order of operations tells us that this will have to be done first. So you'll have negative 1 equals a times 4. 2 times 2 is 4, plus 1. Order of operations again, this is the first thing you do. A times 4 is 4a plus 1. I need to isolate my a, and so this positive 1 needs to go to the other side. Therefore, it would look like, copy this down. The positive 1 turns to negative. Copy the equal sign. This would be 4a. This is negative 2. Divide both sides by 4. And so our a is negative 1/2. So with that said, you know that your graph is being vertically compressed, and you know that it opens downward. So this is a wider graph, wider opening. So your equation would look like y equals, the a stays in the front, the x stays there, and then minus 2 squared plus 1. That is your equation. So let us now start graphing. So our graph would look like this. It says that the vertex is at 2, 1. So this is your vertex right here. And this is 2, 1. And it says that your point is 4, negative 1. So that is 1, 2, 3, 4. Negative 1 is here. You can see that the opening is down. And you can see that your graph is being vertically compressed because it's wider opening. Every quadratic equation or function is symmetrical. So therefore, you know that if this is your axis of symmetry, that the other point is here. So therefore, approximately your graph is going to be like that. Okay, our last example, example 3, has a vertex of 0, 1, and a point of negative 2, 3. So our equation again is y equals a times x minus h squared plus k. You know that this is your hk, this is your xy. We substitute them all to get the a. Again, a is important because you wanted to know how it opens. Does it open up? Does it open down? Is it wide? Is it narrow? So let's begin. It says here that y is 3, so I'm going to put it there, 3. A is what we're looking for. Parentheses for x, we will plug in later. Parentheses for h, we will plug in later. Close it. Copy the 2. Copy the plus. Parentheses for k. So, x is -2. H is 0. K is 1. So, let's do this. Order of operations states that you do the parentheses first. In this case, it is 2 minus 0. -2 minus 0 is -2. Square it, copy the squared, and then copy the plus, copy the 1. Order of operations states that you will have to do after the parentheses exponent. So -2 times itself is +4 plus a 1. This is the first thing that you will do. So you will have 4a plus 1. To isolate the a, this has to go to the other side. Therefore, this side would look like this. And this will be a 2. Divide both sides by 4. Your a is +1/2, which this means that your graph opens up, and this is wide because it's being compressed. Your equation now would look like this. Y equals 1/2 x minus 0. Let's just write that down. Plus 1. However, you have to fix that. So your y is equal to 1/2 parentheses x squared outside plus 1. This is your equation. I know some of you are asking why we replaced the h and the k, but we did not replace the x and the y. Well, it's because we're talking about equation of a parabola. Therefore, we can replace the x and the y with any point, infinite number of points in your graph. So, let's go ahead and graph this. Okay, so how do we graph this? Let's see. It says here that your vertex is 0, 1. So that's your vertex. And it says that your point is -2, 1, 2, 3. So this is your -2, 3, and that's your point. This is your vertex, which is 0, 1. And it goes up like this. Again, it is symmetrical, so you know that the distance here will be the same. Your other half will be on here.